Good day, students. So today we'll be looking over factorizing, but in specifically factorizing the difference between two squares, right? So let's just look at the theory first. What is a square? What is a perfect square? What's all of that? So a square is just like anything to the power of two. That's a square. And a cube is like anything, whatever, to the power of three. All right. Now let's look at a perfect square. What is a perfect square? It is a number, right? That when you put a square root over it, you get a whole number. Whatever you put, whatever the number is, but when you put a square root over it, you get a whole number as your answer. Let's look at 2, for example. When you put a square root over 2, do you get a whole number? I want you to type that in your calculator. No, you don't. You get a number with decimals. That's not a whole number. Now let's look at 4. Let's put a square root over 4. What do we get? We get 2. Is 2 a whole number? Yes. Right. So that's just those differences between perfect squares and not so perfect squares. Right. And I would say perfect cubes. Um what 27. If I put a 3 over there, now that's a cube root. What's a cube root of 27? We know that we're going to get 3. Right. So it's just one of those things. 8, you put a cube root over 8. What do you get? You get 2. So we are just checking perfect squares, perfect cubes, all of that. Right. Now let's get on with it. Now we have x squared minus 16. X squared minus 16. Is x squared a perfect square? Yes, because x times x gives you x squared. So when you square root x squared, in essence, what are you going to get? You're going to get x. All right, so that is a perfect square. You look at 16, you put a square root over 16. What are you going to get? You're going to get 4. So these numbers are very important. Well, the values that you got after square rooting these are very important. After square rooting x squared, you got x. After square rooting 16, you got 4. Now let's open up our brackets and let's factorize. We have x squared. So what was the square root of x squared? It was x. We just put that number in these two places. They're going to come first. And then, very important, this chapter is called the difference of two squares for a reason. These are two perfect squares and there's a negative in between, right? That's the difference that they're talking about. And how do you get a negative? Well, you must multiply a negative with a positive. That is what we're going to do here. We have a negative, we have a positive. Whether the positive is that side, negative that side, doesn't matter. But as long as it's negative and positive. And now we're at 16. What was the square root of 16? Well, it was 4, right? So we just put that 4 over there. And how do we know that this is correct? Well, we need to check. So you don't write what I'm going to write underneath your answer. You just find a free space wherever and you just check for yourself. Now we're going to FOIL that. X times x, okay, we get x squared. X times 4, we get positive 4x. Negative 4 times x, okay, that's negative 4x as well. Then negative 4 times 4, that's just negative 16. We look at the like terms, though these two are going to cancel, then we are left with x squared minus 16. Okay, we got back to where we started. Is that correct? Yes, we need to go back where we initially started. Now let's move on to another question. Move on to another question. Now this one contains a fraction. So we have x squared minus a quarter. Now, what do you get when you square root x squared? We get x. Okay. Now, this is 1 over 4. And when you put a square root over there, it can also mean that you're just square rooting these two things, individually. All right. So what is the square root of 1? The square root of 1 is 1. And what is the square root of 4? The square root of 4 is 2. So a half. So a half times a half will give us a quarter. We know that. So let's open up our brackets. Let's open up our brackets. Okay, so we got an x. So we know that need to have an x over there and an x over there. All right. Because x times x must give us x squared again. Now this is a difference. Why do we need to make that negative? We need that negative and we need that positive over there. And what did we get as our square root of our quarter? We got a half. And it's easy as that. And then you're all done. Then you're all done. Let's move on to the next question. Now we have 2x all squared minus 9. Now we need to take BODMAS into account, right? So we need to solve this bracket first before we factorize. So we need to simplify first, right? Now 2x all to the power all squared, right? Now what's 2 to the power of 2? That's 4x squared minus 9. Is 4 perfect square? Yes. What do we get when you square root 4? We get 2, right? So let's just open up our brackets. What do we get when you square root 4? We get 2. And when you square root x squared, we get x. So we write that same number on this side. We put in our signs, a negative and a positive. Now, what do we get when we square root 9? We get 3, 3, right? And then when we want to check, we're going to FOIL this and see if we land back over here, right? And we're done. We're done with that. So once you get in to the groove of things, this is just going to be a walk in the park, right? It's just going to be a walk in the park. Now, there's a mistake here. This is supposed to be no. This question. I need to recheck it. But nevertheless, that is all for today. That is all for today. I will need to check that question. I'm not quite sure why I put that there. I don't think it was supposed to be there. But yeah, I hope you all understood. I hope you all understood what is happening here. And that is basically it with difference of two squares.